Assalamu alaikum dear friends, you are watching Study with Sheraz, and in today's lecture we are going to talk about the half-life of radioactive materials. It's basically the time period during which one half of the total number of the radioactive material or the radioactive isotope disintegrates or it changes into another nuclei. Suppose if we have 1000 number of atoms at the start of process, so after one half-life it would be decreased to the 500. So it means that it's the time period during which one half of the radioactive atom are disintegrated and one half is left behind. But we cannot count the number of atoms by a conventional method. So an other way to define the half-life is it's the time period during which radioactivity of a substance falls to one half of its original value at the start. Because we can measure the radioactivity by large number of methods, we have two lectures on the measurement and detection of the radioactivity. So using that methods, we can measure the extent of radioactivity, and from that we can measure the number of disintegrations that are occurring per second. We would follow the radioactivity and the time period during which the extent of radioactivity become one half. That would be known as the half-life of the radioactive element. Now we are going to derive the expressions for the half-life of the radioactive material. So let initial concentration or the initial amount of the substance is N0, and after time t, the remaining amount undisintegrated is N. So amount disintegrated is N0 minus N, because N0 is the initial amount or initial number of the radioactive atoms, N is the number of atoms left undissociated after the time t. So amount disintegrated is equal to the difference between the number of atoms at start and number of atoms at the time period t. So if t 0.5 is the half-life and time t is equal to the n half-lives. So basically a half-life is represented by t 1 by 2 in this manner. So 1 by 2 also means 0.5. So if t 0.5 is the half-life and the time period t that has passed during this chain is equal to the n number of time t 0.5. So t is equal to n into t 0.5, and we can find the number value of n, that is n is equal to t over t 0.5. We would use this factor n later. So after one half-life, the amount of substance undisintegrated is 1 by 2 n naught. As I have given you the example that if the number of atoms at the start of the process is 1000, so after one half-life, the number of atoms remaining would be 500. That's one half of the number of atoms at the start. So if n naught is the number of atoms at start, so after t 0.5, the number of undisintegrated atoms would be 1 by 2 n naught. Amount disintegrated. So this is n and this is n naught. So n naught minus n, as we have shown here. So number of atoms disintegrated is equal to n naught minus 1 by 2 n naught, and that becomes equal to 1 by 2 n naught. Process of disintegration goes on moving, and a large number of successive half-lives are passing, and again the number of atoms is halving. So after two half-lives, the undisintegrated amount is 1 by 4 n naught. Basically it's equal to the 1 by 2 into 1 by 2 n naught. So after two half-lives, if the number of atoms was 1000 at start, so after one half-life it was 500. After two half-lives it was 250 atoms. So again and again it's becoming half. So that's equal to 1 by 4 n naught. So amount disintegrated, so now this is n. So n naught minus 1 by 4 n naught. If we take the LCM, so 3 by 4 n naught. The number of half-lives can be infinity. So we take the n. So after n half-lives, the amount undisintegrated is equal to 1 by 2 raised to power n into n naught. as we have done here 1 by 2 into 1 by 2. So these, it may be 1 by 2 into n number of 1 by 2. So we have made it 1 by 2 raised to power n and n naught. Amount disintegrated after n half-life is equal to n naught minus 1 by 2 raised to power n into n naught. We simplify it, so 1 minus 1 by 2 raised to power n into n naught. Because we have taken n naught in common here, so this equation has become 1 minus 1 by 2 raised to power n into n naught. So here factor n and factor n can be replaced with this factor. So after n half-lives, the amount undisintegrated is equal to n into 1 by 2 raised to power t divided by t 0.5. So we have put this value at the place of n here, and same value is put here. So amount disintegrated is equal to n naught into 1 minus 1 by 2 t over t 0.5. So just we have modified these equations by putting the value of n from this equation. So we have put the value of this here and here. So these equations have become by putting the value of n. So this was all about the half-life of the radioactive material. So if you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.